Dear students, this is Dr. K. Saravanan, Associate Professor, Department of Information Technology, R&D Engineering College. My dear students, now we are going to discuss stepper motor interfacing with 8051 in detail. In this section, we will see how to connect a stepper motor with Intel 8051 microcontroller. Before discussing the interface techniques, we will see what are the stepper motors and how they work. Stepper motors are used to translate electrical pulses into mechanical movements. In some disk drive, dot matrix printers and other different places the stepper motor are used. The main advantage of using the stepper motor is the position control. Stepper motors generally have a permanent magnet shaft that we call as rotor, and it is surrounded by the stator. The stepper motor is used in applications such as dot matrix printer, robotics, etc. It has a permanent magnet rotor called the shaft, which is surrounded by the stator. Commonly used stepper motor have 4 stator windings too. The normal stepper motor shaft can move freely, but the stepper motor shaft move in fixed repeatable increments. Such motors are called 4 phases or unipolar motors. Some parameters of stepper motors are step angle, steps per revolutions, and steps per seconds, and RPM. We'll see one by one. The step angle. The step angle is the angle in which the rotor moves from one pulses is applied as an input of the stator. This parameter is used to determine the position of stepper motor. Steps per revolutions. This is the number of step angles required for a complete revolutions. So the formula is 360 degree divided by step angle. Coming to the steps per second, this parameter is used to measure a number of steps is converted in each second. RPM. The RPM is the revolutions per minute. This it measures the frequency of rotations. By the parameter, we can measure the number of rotations in 1 minute. The relations between the RPM steps per revolutions and steps per second is like the steps per second is equal to RPM into steps per revolutions. Coming to the stepper motor with interfacing with 8051, where we are using port P0 of 8051 for connecting the stepper motor. Here ULN 2003 is used. This is basically high voltage, high current transistor array. Each ULN 2003 has 7 pins NPN that we call as Darlington pairs. It can provide high voltage output with common cathode clamp, diodes for switching, and inductive leads. The unipolar motor works in 3 modes, that is wave drive mode. In this mode, one coil is energized at a time, so all 4 coils are energized one after the another. This mode provides less torque than full step drive mode. The following table says the winding A0, winding B, winding C, and winding D. The steps is 1, 2, 3, 4. 1 represents the energizing the winding A, and next step is by energizing the winding A and B, then B and C, then C and D. This is for clockwise direction. For counterclockwise direction, first step A and B get energized, and second step B will be energized, and third step C will be energized, and fourth step G will be get energized. In full drive mode, that is, in this mode, 2 coils are energized at the same time. This mode produces more torque. Here the power consumption is also very high. When take this example, that is AB and BC and CD will be get energized, and fourth step only the coil A and D will be get energized. When we talk about the off drive mode, in this mode only 1 and 2 coils are energized alternatively. The first 1 coil is energized, then 2 coils are energized. Then this is basically a combination of wave and full drive modes. It has increased the angular rotations of the motor. That is, suppose we have 8 steps. That is, we have 4 windings A, B, C, D. Initially, the first step, coil A will be get energized. Now, second step, coil A and B will be get energized, and third step, the B will be get energized, and fourth steps B and C coil will be get energized, and fifth step C will be get energized, and sixth step and C and D coil will be get energized, and seventh step only D will be get energized, and the eighth step the coil A and D will be get energized. As I told earlier, the step angle is defined as minimum degree of rotations with a single step, number of steps per revolutions, that is 360 degree per step angle, steps per second, that is equal to RPM into steps per revolutions, that is by 60. For example, the step angle is equal to 2 degree, the number of steps revolution is equal to 180. Thank you so much students for listening my lecture. Thank you.